I wasn't looking for underground schools, but then I found the blueprints. Some of the documents you see from the era that show these structures, they appeared in municipal archives tucked between sewer plans and street layouts. Nothing marked them as significant, but something about them refused to settle. The scale was wrong, the depth too extreme, and the sheer complexity of the chambers suggested a purpose I couldn't reconcile with the official timeline. They were educational facilities, lecture halls, classroom complexes of staggering architectural ambition. And according to the historical record, they shouldn't exist. It began with a single blueprint. Certain documents from the period depicting subterranean construction, vaulted ceilings 20 feet below street level, ventilation systems that would require engineering calculations, we're told didn't exist in frontier settlements. The notation identified it as a municipal school beneath a city hall in a settlement barely 15 years old. 15 years from wilderness to this. The blueprint showed more than foundation work. Vaulted ceilings, ventilation shafts with calculated airflow, classroom chambers with acoustic treatments. Blackboard mounting systems requiring engineering precision. The detail was extraordinary. Load-bearing columns positioned with mathematical exactness. Air circulation paths mapped with the kind of specificity that demands understanding of underground atmospheric dynamics. Natural lighting systems involving reflective surfaces and precisely angled shafts to redirect sunlight into chambers that would otherwise exist in permanent darkness. This wasn't a basement. This wasn't storage space hastily excavated beneath a civic building. This was a purpose-built underground educational facility designed with sophistication that rivaled surface structures in established European cities. The blueprint dated the structure to 1847, 20 feet below what was supposedly virgin prairie. I started collecting similar documents: Chicago's official founding place's permanent settlement at 1833, Fort Dearborn, wooden structures, muddy trading post. By 1852, the city had completed an underground educational complex that extended 3 levels below street surface. The documentation shows 42 separate chambers, each with ceiling heights exceeding 12 feet. Ventilation shafts running from the lowest level to street openings positioned to capture prevailing winds. Stone staircases descending in calculated spirals to preserve structural integrity while minimizing excavation volume. 19 years from frontier outpost to this. Denver told the same story. The settlement established in 1858 during the Pikes Peak Gold Rush. Tent city prospectors, merchants operating from temporary structures. Municipal records indicate completion of subsurface lecture facilities by 1867. The plans reveal chambers capable of seating over 200 students, carved into bedrock and finished with plastered walls. Acoustic engineering sophisticated enough to allow instruction without artificial amplification. Natural light systems using angled shafts and polished metal reflectors to illuminate spaces 3 stories underground. Melbourne, colonized 1835. Underground school complex documented by 1854. The architectural drawings that survive show ventilation calculations accounting for seasonal temperature variations. Water management systems preventing groundwater infiltration. Support columns positioned according to load distribution principles that wouldn't be formalized in engineering texts for another generation. Buenos Aires, San Francisco, Montreal, Irkutsk. Each city presented the same chronology. Recent settlement followed almost immediately by the construction of elaborate subterranean educational infrastructure. Not simple excavations, not converted cellars, but purpose-designed teaching facilities demonstrating engineering knowledge that frontier conditions couldn't produce. The pattern was impossible to ignore. Let's examine what these blueprints actually show. The ventilation systems aren't rudimentary. They demonstrate understanding of air pressure differentials, thermal convection, and atmospheric circulation that would require empirical testing and mathematical modeling. The shaft positioning accounts for prevailing wind patterns. The intake and exhaust placement creates passive airflow sufficient to maintain breathable atmosphere in chambers holding dozens of occupants for extended periods. Without mechanical assistance, without the physics that would explain how such systems function. The structural engineering presents similar problems. These aren't shallow cellars dug beneath buildings. They're multi-level complexes extending 20 to 30 feet below grade. The ceiling spans in some chambers exceed 40 feet without visible support columns. The load calculations required to prevent collapse, the soil mechanics necessary to ensure stability, the waterproofing techniques to prevent flooding from groundwater tables, this knowledge doesn't emerge spontaneously in boomtowns populated by miners and merchants. Some of these documents from different continents, different decades, reveal architectural elements that appear standardized. The classroom dimensions repeat with disturbing exactness: 12 feet ceiling height, 24 feet chamber width, support columns spaced at 16-foot intervals. The proportions aren't approximate. They're identical, as if the designers were working from a common template, following specifications that transcended geographic and temporal boundaries. This presents a coordination problem. We're expected to believe that architects in North America, South America, Australia, and Siberia independently arrived at the same solutions for underground educational design, that they determined the same optimal classroom dimensions without communication, that they mastered the same ventilation engineering, the same structural calculations, the same waterproofing methodologies through separate development paths that somehow converged on identical results. The official explanation relies on convergent evolution, similar problems producing similar solutions across isolated development. But convergent evolution doesn't explain identical measurements. It doesn't account for standardized component specifications. And it certainly doesn't explain why these facilities appeared simultaneously across 6 continents during the same narrow window of historical development, in locations that supposedly lacked the institutional framework to produce such expertise independently. The evidence points to something far more systematic. Where did the expertise come from? Not the raw materials, though excavating at that depth poses its own challenges, but the knowledge. The architectural training required to design stable underground chambers, the engineering calculations necessary for those ceiling spans without intermediate supports, the ventilation science behind maintaining breathable air in sealed environments, the structural analysis demanded to prevent groundwater infiltration in chambers carved below the water table. You don't develop that expertise in frontier conditions, you inherit it. Consider what these projects actually required. Underground construction at this scale demands precise understanding of soil mechanics. Different soil types exert different lateral pressures on retaining walls. Clay behaves differently than sand, bedrock differently than glacial till. The engineers designing these facilities had to account for these variations, had to calculate load-bearing capacities, had to determine appropriate wall thicknesses and support spacing based on geological conditions they were encountering for the first time in these specific locations. This isn't intuitive knowledge. It's not the kind of understanding you gain through trial and error. Not when failure means catastrophic structural collapse in an occupied educational facility. It represents systematic study, empirical testing, accumulated expertise refined through generations of practice. But whose generations? Where did that accumulated knowledge originate? The ventilation systems reveal similar problems. Passive air circulation in underground environments requires understanding of thermal dynamics, pressure differentials, and atmospheric flow patterns. The shaft placement in these designs accounts for seasonal wind direction changes. The intake and exhaust positioning creates convection currents that maintain consistent air exchange without mechanical assistance. Some blueprints show dampening chambers to reduce temperature fluctuations, positioning of air channels to prevent downdrafts, and calculations for oxygen replenishment rates based on occupancy levels. We're told that frontier architects simply possessed remarkable intuition, that practical experience compensated for lack of formal training, that necessity drove innovation and produced results through determined effort and natural ingenuity. Yet the designs demonstrate knowledge that extends beyond practical experience. They show understanding of principles that wouldn't be codified in engineering literature until decades later. The mathematical relationships between chamber volume and ventilation shaft diameter, the optimal angles for light reflection in subsurface environments, the thermal properties of different building materials when used below grade. How did builders working in the 1850s and 1860s know what engineers in the 1890s would still be discovering? Certain documents from the period depicting these underground facilities reveal details that professional structural engineers find remarkable. The consistency of design principles across geographically separated projects. The same solutions to water management appearing in cities with completely different water table depths and soil compositions. The same acoustic treatments, the same lighting approaches, the same proportional relationships between chamber dimensions and ceiling heights. As if the designers weren't solving problems independently, as if they were following established guidelines, implementing proven solutions, working from a knowledge base that already existed in complete form. This presents more than a coordination problem. It suggests the existence of an educational infrastructure capable of training architects and engineers in these specialized techniques. Institutions where such knowledge could be preserved, taught, and refined. A system for disseminating this expertise to multiple locations across vast distances. But no such institutions appear in the historical record. No schools teaching underground architectural design in the 1840s. No engineering academies focused on subterranean construction techniques. No professional societies publishing research on ventilation dynamics or subsurface structural engineering. The knowledge appears fully formed, implemented with confidence and precision, then vanishes from the architectural repertoire as if it had never existed. Where it came from and where it went remain questions the official chronology cannot address. Certain photographs from construction sites reveal their own anomalies. Not the structures themselves, but who built them. The workers in these images don't match the demographic profile we'd expect. We're told these facilities rose in boom towns populated by prospectors, migrants, and merchants. People chasing economic opportunity, not trained in specialized construction techniques requiring years of apprenticeship. Yet the work demanded expertise that goes far beyond basic excavation. Stonework fitted with precision that leaves no visible gaps between blocks. Plastering techniques that remain intact after 170 years of groundwater exposure. Waterproofing applications requiring knowledge of chemical interactions between different sealant compounds and varying soil compositions. Ventilation shaft installations demanding precise angular calculations to achieve proper airflow dynamics. Support column positioning based on load distribution analysis that modern structural engineers recognize as mathematically sophisticated. Where did these workers come from? The documentation is sparse. Employment records from this period rarely survived. The few that did show unusual patterns. Sudden influxes of European craftsmen appearing for specific projects, then vanishing from the historical record. No immigration documents tracing their arrival. No subsequent employment linking them to other construction projects. No family lineages establishing their presence in the communities they supposedly helped build. They arrived, they built, they disappeared. And this is the most peculiar part. The speed. I obtained building permits and municipal records from several cities. When these documents exist, and often they don't, they reveal timelines that border on impossible. An underground school complex in Sacramento. Foundation to completion in 11 months. The structure contained 38 separate teaching chambers across 2 subterranean levels. Ventilation systems requiring the drilling and lining of shafts extending 40 feet to street level. Stone staircases carved from bedrock and finished with handrails showing decorative ironwork. Support columns installed with precision that modern contractors struggle to match even with laser surveying equipment and hydraulic placement tools. 11 months. Not the reason, not the timing, not the conditions. How the pattern resurfaces with disturbing exactness. Melbourne's underground facility, 14 months from groundbreaking to the documented opening ceremony. A complex in Buenos Aires, 9 months from excavation start to the first recorded classes. These aren't reasonable timelines even with modern construction methods, powered equipment, and coordinated logistics. With hand tools, horse-drawn transport, and the communication limitations of the mid-19th century, the sanctioned explanation falls apart at this point. We're told that determination and available capital can accomplish anything. That American entrepreneurial spirit overcame logistical limitations through sheer force of will and economic motivation. That skilled workers simply achieved remarkable efficiency through necessity and competition. That frontier conditions bred innovation and produced results that surpass what modern capabilities can achieve. But efficiency has limits, physics has constraints. And the photographic evidence shows results that shouldn't exist within those constraints. The excavation alone presents problems. Removing thousands of cubic yards of earth and rock from depths exceeding 20 feet requires not just labor but organized systems for material removal, structural shoring during the digging process, and continuous water management to prevent flooding from groundwater infiltration. The timeline documents suggest crews were simultaneously excavating, installing support structures, finishing interior surfaces, and constructing ventilation systems. Parallel workflows that demand coordination exceeding what we'd expect from supposedly improvised frontier construction projects. Some of these images from different continents, different decades, show components that appear mass-produced, not roughly similar, identical. Certain ventilation grates with the same decorative ironwork patterns. Support column capitals featuring matching ornamental details. Door frames with standardized dimensions and identical hinge placements. Staircase railings showing the same baluster designs down to the smallest decorative flourish, as if produced from the same molds, installed by workers following the same instructions, implementing designs drawn from the same source. Municipal records occasionally reference material shipments, but the details are vague. Ironwork from Eastern foundries, stonework from European suppliers. No specific manufacturer names, no foundry locations, no shipping manifests detailing quantities or specifications. The components arrived, were installed with precision that suggests prior familiarity with their assembly, and the documentation trails end there. The work required more than generic construction labor. It demanded specialized knowledge that leaves specific signatures in the finished product. The stone cutting shows techniques associated with traditional European masonry guilds. The plastering exhibits methods used in Mediterranean climate control applications. The ironwork demonstrates forge techniques documented in Central European industrial centers, skills that take years to master, appearing in frontier settlements where no infrastructure existed to teach or preserve such expertise. Where were these workers trained, and why does their presence in the historical record remain so systematically erased? Some of these images from different continents, different decades, reveal components that appear mass-produced. Not roughly similar, identical. Certain balcony railings in underground lecture halls show the same decorative patterns, whether photographed in Chicago or Melbourne. Ventilation grate designs repeat across facilities separated by 8,000 miles. Door hardware, lighting fixture mounts, even the ornamental brackets supporting classroom blackboards, all displaying standardized dimensions and matching decorative elements. This prompts a straightforward yet vital question. Where were these components manufactured? The industrial infrastructure required to produce such elements at scale, the foundries capable of casting identical ironwork in quantity, the workshops maintaining quality control across multiple production runs, the logistics systems coordinating shipments to distant locations should leave traces, factory records documenting output, shipping manifests detailing destinations, patent applications for the specialized designs and manufacturing techniques involved, invoice ledgers tracking payments and deliveries. These records don't exist. Instead, we find silence. Gaps in the archival record precisely where documentation should be most robust. Municipal files with missing pages covering the years these facilities were constructed. Shipping ledgers with entries removed, leaving blank spaces in otherwise continuous logs. Building department records that were lost to fire or damaged by water at remarkably convenient moments. Always destroying documentation for these specific projects while leaving surrounding files intact. The absence of documentation is itself documentation. It reveals what someone didn't want preserved. Consider the coordination this required. Multiple cities across 6 continents receiving identical components during the same narrow historical window. Each component arriving exactly when needed for its specific installation point in the construction sequence. No documented delays, no recorded shipping errors, no evidence of the logistical challenges that should accompany such geographically dispersed distribution of standardized materials. The components simply appeared, were installed by workers who demonstrated familiarity with their assembly despite no documented training, and the paper trail documenting their production and distribution vanished as thoroughly as the workers who installed them. Manufacturing at this scale requires industrial capacity, foundries capable of producing tons of cast iron components, quarries supplying uniformly dimensioned stone elements, workshops fabricating wooden fixtures to precise specifications. The facilities, the workforce, the fuel supplies, the transportation networks, all the infrastructure supporting mass production of building components in the mid-19th century existed in established industrial centers. Manchester, Pittsburgh, the Ruhr Valley, places with documented manufacturing histories, preserved business records, and traceable industrial development. Yet none of these documented industrial centers show any record of producing the components appearing in underground schools across the globe. No foundry claiming credit for the standardized ironwork. No quarry advertising their stone products installed in prestigious educational facilities. No manufacturer preserving contracts or correspondence related to these massive construction projects that should have represented significant commercial opportunities. The production capacity existed somewhere. The components are real, they're installed, they're still present in the surviving structures. But the source of their manufacture remains systematically obscured. Factory records that should exist don't. Company archives that should document major contracts contain nothing. Industrial centers that should proudly reference their role in these projects maintain complete silence. Where did this coordination originate? Who organized the production and distribution of standardized components to construction sites separated by thousands of miles? What communication system allowed such precise timing that materials arrived exactly when needed despite the transportation limitations of the era? The official explanation offers market forces and entrepreneurial efficiency, that commercial networks simply functioned with remarkable effectiveness. That documentation was lost through ordinary archival neglect rather than systematic removal. That the coordination was less precise than it appears, and we're simply noticing the successes while forgetting the failures that left no trace because incomplete projects were abandoned and forgotten. But abandoned projects leave their own evidence: unused components, partial structures, financial records of failed investments. The absence of failure documentation is as suspicious as the absence of success documentation. The pattern suggests not ordinary commercial activity with its expected mixture of achievement and setback, but something operating with unusual efficiency and leaving minimal archival footprint. One of many forgotten documents shows engineering details that modern specialists find remarkable. The ventilation shaft positioning, the air intake calculations, the temperature regulation achieved without mechanical systems, these aren't improvised solutions. They demonstrate sophisticated understanding of atmospheric dynamics, thermal transfer, and environmental control in sealed underground spaces. The ventilation systems maintain breathable air quality in chambers 20 to 30 feet below street level. In some cases, 3 full stories underground. The passive circulation creates consistent air exchange rates sufficient for rooms holding 50 to 70 occupants for hours at a time. No fans, no pumps, no mechanical assistance of any kind documented in the construction records. Modern environmental engineers measuring these spaces find airflow patterns optimized with mathematical precision. Intake shafts positioned to capture prevailing winds regardless of seasonal variation. Exhaust vents, placed to maximize thermal convection currents, dampening chambers that moderate temperature fluctuations between surface and subsurface environments. Air channel dimensions calculated to prevent turbulence while maintaining sufficient flow velocity. This level of design requires empirical testing, mathematical modeling, and deep understanding of fluid dynamics as applied to atmospheric circulation. The builders needed to account for air pressure differentials at varying depths, thermal stratification in vertical shafts, and humidity control in enclosed environments with significant occupancy loads. They had to determine optimal shaft diameters based on chamber volumes, calculate required airflow rates per occupant, and position intake and exhaust points to create reliable circulation patterns without mechanical forcing. We're told that frontier architects simply possessed intuitive genius, that practical experience and necessity produced these results. That trial and error, guided by common-sense observation, led to solutions that modern engineers recognize as technically sophisticated. Yet the science of underground environmental control wasn't formalized until the late 19th century. Systematic study of ventilation dynamics in sealed spaces didn't occur until mining operations and subway construction demanded mathematical approaches to air management. The principles governing passive airflow in multi-level underground structures weren't codified in engineering literature until the 1880s and 1890s, decades after these educational facilities were already functioning with ventilation systems that demonstrate those very principles. How did builders in the 1850s and 1860s know what scientists hadn't yet proven? How did they implement solutions that wouldn't be theoretically validated for another generation? The temperature regulation presents similar impossibilities. These underground chambers maintain remarkably stable environments. Modern thermal monitoring shows temperature variations of less than 5 degrees Fahrenheit across entire seasonal cycles. The spaces remain cool in summer, moderate in winter, without any documented heating or cooling systems beyond the passive thermal mass of surrounding Earth. But achieving this stability requires understanding principles that weren't formally recognized in the mid-19th century. The thermal conductivity of different soil types, the insulating properties of stone and brick at various thicknesses, the relationship between depth, thermal mass, and seasonal temperature buffering. The positioning of chambers relative to groundwater tables to leverage natural cooling effects. This knowledge doesn't emerge from guesswork. It represents inherited expertise, refined through generations of empirical observation and systematic testing. Knowledge accumulated over time, preserved in training systems that taught principles before science explained why those principles worked. The further I went into technical studies of these surviving structures, the more troubling the picture became. Acoustic engineers analyzing the teaching chambers find sound distribution properties that shouldn't exist without deliberate design. The ceiling curves, the wall angles, the floor materials, all positioned to eliminate echo while maintaining clear voice projection from instructor positions to student seating areas throughout the space. Modern acoustic consultants measuring these underground lecture halls find reverberation times optimized for speech clarity, reflective surfaces positioned to reinforce vocal frequencies while dampening ambient noise, chamber dimensions that prevent standing wave formation at frequencies that would interfere with verbal instruction, design choices that demonstrate understanding of sound propagation principles that wouldn't be formally studied until Wallace Sabine's groundbreaking work in the 1890s. The builders implemented acoustic engineering that predated the science of architectural acoustics by 4 decades. They carved teaching spaces from bedrock that demonstrate principles scientists hadn't yet discovered. And they did this not in one isolated case, but systematically across multiple continents in dozens of geographically separated facilities. But whose expertise? And where did those generations of refinement occur? Around the turn of the 20th century, something changed. Subsurface structures built after 1900 lack the characteristics of their predecessors. The environmental control systems simplify, the acoustic sophistication diminishes. The engineering becomes more conventional, more recognizably derivative of established industrial practices, rather than demonstrating knowledge that seems to precede formal science. Some of these images from that transitional period show hybrid buildings, attempts to replicate earlier achievements that fall demonstrably short. An underground school addition in Chicago from 1903 shows ventilation shafts positioned according to the earlier pattern, but the airflow proves inadequate. The chamber suffers from poor circulation, requires mechanical fans to maintain breathability. A facility in Denver constructed in 1907 attempts the passive temperature regulation of earlier structures, but fails to achieve the same stability. The spaces require heating systems, supplemental cooling, mechanical interventions that the earlier chambers never needed. The details are coarser, the proportions slightly wrong. The environmental results measurably inferior. Not a gradual evolution, a rupture. Construction practices after 1900 show increasing reliance on mechanical systems to achieve what earlier builders accomplished through design alone. Ventilation becomes a matter of installing fans and ductwork rather than positioning passive air channels with mathematical precision. Temperature. Control shifts to furnaces and later to refrigeration units rather than leveraging thermal mass and strategic depth positioning. Acoustic treatments become additive, applying sound dampening materials to surfaces rather than shaping the spaces themselves to control reverberation. The knowledge that produced the earlier structures had evaporated. What happened? The official narrative offers industrial progress, changing building codes, shifts in educational philosophy that favored different classroom configurations, economic factors that made mechanical systems more cost-effective than elaborate passive designs, cultural changes in architectural aesthetics that moved away from ornate underground construction toward simpler, more utilitarian approaches. But those explanations don't account for the loss of capability. Societies advance, they build on previous knowledge. They refine existing techniques and improve upon earlier achievements. They don't suddenly forget how to accomplish what they'd mastered a generation before. They don't abandon superior solutions in favor of inferior approaches that require ongoing mechanical intervention and energy expenditure, unless the knowledge was never theirs to begin with. The timeline suggests something beyond cultural shift or technological change. Between roughly 1890 and 1905, the capacity to design and construct sophisticated underground educational facilities simply disappeared. Not gradually, not through evolution of practice, but abruptly. The last examples showing the full sophistication appear in the early 1890s. By 1905, everything constructed demonstrates conventional engineering, without the unexplained refinements that characterized earlier work. 15 years. The transition from mastery to loss of capability compressed into a single generation, as if access to the knowledge base had been severed, leaving subsequent builders to work from incomplete understanding, attempting to copy results they could observe but no longer fully comprehend. I reached out to architectural historians, structural engineers, municipal archivists. I asked simple questions. Where did the expertise originate? How were these timelines achieved? Who designed the standardized systems appearing across continents? Why did the capability vanish after 1900? The silence was overwhelming. Not hostility, not defensiveness, just disinterest, as if the questions themselves were irrelevant. The few responses I received followed a predictable pattern. The buildings exist, therefore they were built. The construction timelines are documented in municipal records, therefore they're accurate. The architectural sophistication reflects the skill available at the time. Therefore, no mystery exists. Circular reasoning that mistakes documentation for explanation, that treats the existence of records as proof of their completeness, rather than recognizing what those records conspicuously fail to address. Some historians engaged initially, acknowledging the unusual consistency of design elements, the remarkable construction speeds, the sophistication of engineering solutions. But when pressed on specific mechanisms, how the knowledge transfer occurred, where the workers were trained, why the capability disappeared, the engagement ended. They retreated behind the same refrain. Insufficient evidence for alternative explanations. Insufficient evidence. The buildings themselves are evidence. The blueprints are evidence. The impossible timelines, the unexplained expertise, the global coordination, the standardized components, the advanced engineering predating formal science, all evidence. The systematic gaps in archival records where documentation should exist, that's evidence too. The convenient destruction of files precisely covering these construction periods, evidence. The absence of manufacturing records, shipping manifests, worker employment documentation, evidence of deliberate erasure. The question isn't whether evidence exists, it's whether we're permitted to examine it honestly. The institutional response reveals its own pattern. Museums with underground sections in their buildings decline to provide access for independent structural analysis. Municipal archives restrict access to construction records from the mid-19th century, citing fragility of documents that researchers are never allowed to verify. Universities with architectural history departments show no interest in comparative studies of subsurface construction techniques across continents. Preservation societies focus their documentation efforts on surface structures while systematically ignoring the elaborate underground facilities literally beneath their feet. The lack of curiosity is itself curious. These structures represent remarkable engineering achievements by any measure. They demonstrate construction capabilities that challenge our understanding of 19th century technological development. They raise legitimate questions about knowledge transmission, architectural coordination, and the sudden loss of sophisticated building techniques. Yet institutional scholarship maintains studied indifference, treating these facilities as mundane civic infrastructure unworthy of serious investigation. Professional journals publish articles on minor architectural details of far less significant structures, while ignoring underground schools that predate the science they demonstrate. Academic conferences discuss theoretical questions about 19th century construction practices without addressing the empirical evidence existing in accessible, measurable, photographically documented facilities in major cities. The absence of scholarship on these structures isn't oversight, it's systematic avoidance. When I presented specific technical questions to engineering departments, the responses shifted from disinterest to evasion. How were ventilation calculations performed without the mathematical frameworks formalized decades later? The answer: builders must have used empirical methods we no longer document. Where were workers trained in specialized techniques that left no institutional trace? The answer: knowledge transfer occurred through informal apprenticeship systems that didn't preserve records. Why did these capabilities vanish rather than evolve? The answer: changing economic conditions and building codes made the techniques obsolete. Every answer assumes the conclusion it's meant to support. The techniques must have been conventional because conventional explanations are the only ones permitted. The knowledge must have come from documented sources because undocumented sources aren't academically acceptable. The loss of capability must have natural causes because alternatives challenge the established chronology. A photograph that wasn't meant to stand out shows workers during a basement renovation in the 1970s. They've excavated below the known foundation of a civic building in Philadelphia. What they found changed the renovation plan. Behind the documented 1858 construction lay older work, different stonework, different mortar composition, different construction techniques entirely. The basement they were extending connected to chambers that preceded the building above them. Chambers carved from bedrock using methods the renovation crew couldn't identify. Tool marks that didn't match any documented 19th century excavation techniques. Support structures employing joinery without metal fasteners. Achieving load distribution through shaped stone alone. The findings were sealed. The renovation proceeded according to the modified plan that incorporated the discovered chambers into the expanded basement. And the documentation of what existed before the 1858 structure vanished into municipal storage, where it has never received scholarly examination. This pattern appears in multiple cities where deep renovations occurred. Workers in San Francisco during subway construction in the 1960s found chambers beneath Market Street that weren't on any city engineering maps. The spaces showed finished walls, ventilation connections to the surface, evidence of sustained occupation. No documentation explained their existence. The subway project incorporated them into maintenance access tunnels, and the discovery was noted in internal construction reports that remained classified for infrastructure security reasons. A school expansion in Melbourne in 1988 required excavating adjacent to the documented 1854 underground facility. The construction crew found connecting passages leading to chambers that extended beyond the map structure. Older construction, more sophisticated in some technical aspects, less ornate in decorative elements. The additional chambers were sealed off, excluded from the expansion project, and the architectural drawings were amended to show solid earth where the passages actually existed. Chicago, Buenos Aires, Denver. Each city where sufficient excavation occurred reveals the same finding. Beneath the documented mid-19th century underground schools lie traces of earlier construction. Not primitive precursors, not crude initial attempts later refined into the elaborate facilities we see in photographs. Earlier work that demonstrates equal or greater sophistication using different techniques, as if built by different hands following different design principles toward the same functional goal. What were these structures before they became schools? And why does their earlier form remain so carefully hidden? The renovation discoveries suggest a pattern of reclamation rather than original construction. The documented facilities from the 1850s through 1880s weren't built from virgin excavation. They were modifications of pre-existing underground networks. Adaptations of chambers that already existed when the frontier cities were supposedly founded. The construction timelines that seem impossible become slightly less so if the work involved repurposing and finishing existing spaces rather than creating them from nothing. But this explanation raises more questions than it answers. If these chambers existed before the cities, who built them? The official chronology allows no time for prior construction. The settlements we're examining were supposedly the first permanent occupation of these locations. No previous civilization is documented. No archaeological evidence supports sustained pre-colonial occupation at the scale these underground networks would require. Yet the physical evidence persists. Different construction techniques layered beneath documented work. Tool marks that don't match any recorded methods, materials that shouldn't exist in the supposed construction period. Chambers extending beyond mapped structures into areas that were never officially excavated. The discoveries are consistent across geographically separated cities, suggesting not isolated anomalies, but systematic evidence of something that preceded the accepted timeline. The renovations that revealed these findings all occurred during periods of rapid urban development, when infrastructure expansion demanded extensive subsurface work. The discoveries were inconvenient. They complicated construction schedules, raised questions about structural stability, and threatened to delay projects that had political and economic momentum behind their completion. The pragmatic response was incorporation and concealment. Use what could be integrated, seal what couldn't be explained, and maintain documentation that supported the project timeline, rather than revealing anomalies that would trigger investigation. Let me be precise about what we're examining here. Between approximately 1845 and 1890, cities across 6 continents constructed elaborate subsurface educational facilities using remarkably consistent architectural principles, advanced engineering techniques, and standardized components. This occurred during a period of limited communication, slow transportation, and supposedly independent urban development. The facilities appeared in frontier settlements, colonial outposts, and rapidly growing urban centers, locations lacking the educational infrastructure to train specialized workers, the industrial capacity to manufacture standardized building components, and the institutional framework to preserve and transmit sophisticated engineering knowledge. Yet the construction proceeded with timeline compression that defies reasonable explanation, employed techniques that predated their formal scientific codification, and produced results modern contractors struggle to replicate with contemporary tools and methods. The construction timelines eliminate conventional explanations. The architectural sophistication exceeds documented expertise. The global consistency suggests coordination that shouldn't be possible given the communication limitations of the era. The engineering demonstrates knowledge of principles that science hadn't yet formalized. The standardized components imply manufacturing at industrial scale without leaving archival trace. And precisely where documentation should illuminate these mysteries, we find erasure. Not the gradual loss that time inflicts on all records. Deliberate, systematic removal of evidence. Municipal files missing specific pages covering construction periods. Photographs removed from archival collections with no acquisition records explaining their absence. Building permits with crucial details redacted or destroyed in fires that left surrounding documentation intact. Employment records vanishing for workers who appeared during construction projects and disappeared afterward. Shipping manifests with entries removed, leaving blank spaces in otherwise continuous ledgers. Manufacturing records absent from industrial centers that should proudly document their role in supplying materials for prestigious civic projects. The conventional explanation requires us to believe in remarkable coincidences, that dozens of cities independently decided to prioritize elaborate underground schools, despite lacking basic surface infrastructure. That skilled craftsmen appeared exactly when needed, possessed knowledge beyond documented training systems, worked with impossible efficiency, then vanished without leaving family lineages or subsequent employment records. That architectural expertise emerged fully formed in locations lacking the institutional framework to develop such knowledge independently. That construction techniques exceeding modern capabilities were somehow routine for frontier builders working with hand tools and horse-drawn transport. That engineering principles unknown to contemporary science were nevertheless perfectly implemented in facilities across 6 continents. That identical components appeared in geographically separated projects without documented manufacturing sources or shipping logistics. That acoustic sophistication predating formal study of architectural acoustics appeared systematically in underground teaching spaces. That ventilation engineering implementing principles not yet discovered maintained breathable atmosphere in sealed chambers 3 stories underground. That this explosion of sophisticated construction suddenly ceased after 1900, leaving subsequent generations unable to replicate their predecessors' achievements using the supposedly same knowledge base. And that documentation of all this conveniently disappeared, was destroyed in precisely targeted fires and water damage, or never existed in the first place. How many coincidences before we're obligated to consider alternative explanations? The pattern is too consistent to dismiss as random variation in construction practices. The evidence is too substantial to attribute to archival gaps. The silence is too deliberate to be coincidental neglect. The institutional avoidance is too systematic to represent mere disinterest. Every element points in the same direction, towards something operating beneath the surface of the official chronology, something with capabilities exceeding what frontier settlements should possess, something that left physical evidence while erasing documentary traces, something that was here before our accepted timeline begins. The underground schools weren't simple civic projects. They were repositories of knowledge, educational facilities requiring sophisticated understanding of structural engineering, environmental control, acoustic design, and material science. They appeared in places that couldn't independently produce such knowledge. They demonstrated capabilities that vanished rather than evolved. They left physical evidence that persists despite generations of careful neglect and active suppression. And they raise questions that institutional scholarship refuses to address honestly. A photograph preserved without explanation shows an underground classroom on opening day. The students are seated at desks. The chamber is illuminated. Everything appears as the historical record describes, but look closer. The ventilation grates aren't new. They show corrosion patterns consistent with decades of exposure to moisture and air circulation. The patina on the ironwork suggests far longer service than the documented construction timeline allows. The stone columns bear weathering marks, subtle erosion along edges that indicates extended environmental exposure before the supposed completion date. The mortar between certain stone blocks has been repaired. You can see the slightly different composition where sections were restored rather than originally installed. The plastered ceiling shows texture variations, areas of newer application covering older work beneath. The lighting fixture mounts displayware patterns around bolt holes, evidence of previous installations removed and replaced. Even the floor stones exhibit traffic patterns, worn paths suggesting sustained use before the documented opening ceremony. The chamber wasn't new. It was reclaimed. This detail appears in multiple photographs from different cities, different years. Opening day images presented as documenting newly completed facilities, yet showing physical evidence of prior occupation. Buildings celebrated as recent construction bearing the unmistakable marks of age and restoration. Wear patterns that don't match official timelines. Repair work masquerading as original installation. Components presented as fresh from the foundry displaying patina suggesting decades of previous service. The documentation describes these as construction projects. The photographic evidence reveals them as reclamation efforts. The distinction matters. New construction from virgin excavation requires the impossible timelines, the unexplained expertise. The sophisticated engineering appearing fully formed. Reclamation and restoration of existing structures requires different questions. What existed before? Who built the original chambers? And why present restoration as new construction rather than acknowledging what preceded it? Some images show this more clearly than others. A classroom in Denver photographed in 1868, supposedly completed that year, with ventilation shafts showing mineral deposits requiring decades to accumulate. An underground lecture hall in Melbourne from 1855 with stone columns displaying tool marks from cutting techniques not documented in Australian construction practices of that period. A facility in Buenos Aires with ceiling treatments showing multiple layers of plaster application, the earliest layer using composition not available through documented supply chains serving the city in the supposed construction year. The physical evidence contradicts the chronological narrative. The structures presented as products of rapid frontier construction reveal themselves as modifications of something older. The impossible becomes slightly less so if we're examining restoration rather than creation. But this resolution opens voids in the historical record far more troubling than construction timeline problems. I didn't start this investigation believing in lost civilizations or hidden history. I found blueprints that didn't align with accepted explanations and followed the inconsistencies wherever they led. They led here to underground schools appearing globally within a narrow historical window, constructed with expertise that shouldn't exist, coordinated in ways we can't explain, and documented in records systematically purged of meaningful detail.